Hello students, welcome you all to the video lecture on 8051 assembly language programs. So first let us discuss about the first program, addition of two 8-bit numbers, particularly from the external memory. So whenever it is external data memory, so for example the address is 4200 and 4201, then this data memory which is nothing but external data memory can be pointed out by DPTR, because the external data memory address, it is of 16-bit address. So 16-bit address is pointed out by data pointer which is mentioned by DPTR. So using the DPTR only we are going to point out this address. From that address whatever the data available, those data we are going to add. For example, if the data available is 21, here it is 11. Okay, so these two data we are going to add and then we are going to store that result again in the external memory. So for that, first we have to store this address in the DPTR. So let me move the address, okay, as a immediate data to the DPTR as 4200. Actually it is a 16-bit data which is the immediate data moved to DPTR. Why we are using that means that data, right, which is going to act as a address. From that address whatever the value available, that we are going to add. So whatever the address we are going to mention, that we have to give as a immediate data to the DPTR. Then from that address we can move the data available. So how we can move that data to the accumulator? So generally whenever it is a external data memory, from that we are going to move the data to the accumulator means we have instruction called MOVX. So MOVX, X indicates the external data memory. So from the external data memory we are going to move the data. So which instruction is used means MOVX A comma at of DPTR. So at the rate of DPTR means at the particular address whatever the value available, that will be moved to accumulator. Actually what is DPTR? DPTR is 4200. This will act as a address. From that address whatever the data available, that will be moved to the accumulator. So indirectly you are accessing the data through the address. For that we have to mention at of DPTR. So again we have one more instruction called MOVX at of DPTR comma A, at of DPTR comma A. So this instruction what it will do means whatever the value available in the accumulator, that we can move to the address mentioned by the DPTR. So in the reverse it will do. So we are going to use this instruction first. So why? Because we are going to access this data. This data I cannot access directly, through DPTR only I can access. So for that I am using the instruction MOVX A comma at of DPTR. So what it will do, whatever the value available at the external memory which is pointed out by DPTR is moved to accumulator. So after this instruction A value will become 21. Then what I have to do? I have to point out to the next address. So in order to point out to the next address, what I have to do? I have to increment your DPTR, because I need to point out this address which is nothing but 4201. So use the instruction INC DPTR, increment DPTR. So what it will do? The address 4200 which is there in your DPTR, that will be incremented. So now the data value will be incremented and then now it becomes DPTR value becomes 4201. So here the DPTR value is 4200, right? After giving this instruction, now the DPTR value becomes 4201. So whatever the data available here, that I need to access. Okay. So increment DPTR, now we have to move this value to the accumulator. So again for accessing the external data memory we have only these two instructions. whatever the value available at this address, I can move directly only to the A register. I cannot move to the other register. For example, R0, B, R1, R2 and all I cannot use. Why? Because I have only these two instructions. Okay, I don't have R0 comma at of DPTR and all, B comma at of DPTR I don't have. Only I have this instruction in order to access your external memory. That is, from the external memory, in order to get the data, I have to use only this instruction. So again, you are going to point out the next address. From here, you need to move the data. So if you use MOVX A comma at of DPTR, what happens? Now A becomes 11 because DPTR value is what? 4201. What is the value available here? 11. So 11 will be moved to the accumulator. But again, I need to add these two values. Previously A value is 21. Now A value is 11. That is, 21 is erased and in the same position 11 will be replaced, right? But I want both the data, 21 also I require, 11 also I require. But I have only this instruction to move the data from the DPTR to the accumulator. So what I have to do? I have to save the first value. Okay. So in order to save the first value, before moving the data from the address into the accumulator, what can I do? I can either insert here or insert here, it is your wish. Okay, so I can move or store the value A in one more register. So let me take R0 comma A, so that the first data will be saved in the R0 register, then incrementing the DPTR, then the second data will be moved to the accumulator. So first I am getting A value, that is 21 in the accumulator, and the same value I am moving to R0. So now R0 will be having the value 21. Then incrementing the DPTR, then second data, now it is available in A. Then since it is the addition program, what I have to do? I can just give ADD. Okay, so ADD, one value is available in A, another value is available in R0. Okay, so ADD A comma R0. So what this instruction will do? It will add A register with the R0 and then the result will be stored in your A. So that 21, that is A value, it is 11 and then R0 value is 21. So both will be added. Okay, so what is the value here? It is 32. So 32 will be moved to A register. Okay, so A value will be stored with the value 32. So now again A value is with 32. Either you can stop with this, or if you want to store again this value into the next memory address. Okay, for example, the next memory address is 4202. Okay, here I want to store the result. Okay, so here only I want to store the result, which is nothing but 32. Okay, then I can use what? Increment your DPTR. Okay, so increment your DPTR, so that this will pointing to 4202. There only you are going to store the result. So what you can use? Now A value you are storing in the particular address. So you have to use this instruction. That is, this is source, this is the destination. You are moving the A value to the DPTR. Okay, the address mentioned by the DPTR. So you have to use what? MOVX at of DPTR comma A. Why? Because I am storing the result of A in the address mentioned by DPTR, which is nothing but 4202. So here the result will be stored. Okay, so again here you need to think about one, right? For example, if I have 21 and 11, then I am getting 32 as the result. Suppose if I have a carry, for example, if I am adding F2, hexadecimal value is F2 and here it is 11. Okay, then here it is 3. F plus 1, it is 10. So here 0 and 1 will be the carry. Okay, so the carry will be available whenever if you are adding some two datas. Okay, then I have to think about the carry. If there is a no carry, then there is a no issues. I can store only the value available in A. Suppose if there is a carry, then I need to store that result also. So two more things I have to think about. So after doing the addition operation, I have to think about what, whether there is a carry or not. Okay, so if there is a carry, then I have to do increment some value. If there is no carry, then whatever the value available here, the same thing you can use. So suppose there is a carry, then I have to initialize one more register in order to store your carry. For example, let me add here. Okay, so move R0 comma hash of 00. So this will be acting as a carry register. Okay, so I am initializing the R0 with the value 00. Okay, starting it will be of 00. Suppose there is a carry, then it will be incremented. If there is no carry, it will become 00 as it is. Okay, so after the addition I need to check. So what I have to do? Jump on carry. Okay, so whenever there is no carry, what it can do? It can just increment the DPTR, then it can store the result of A. Okay, then it can store the R0 value as 00. So whenever there is no carry, it will do these operation as it is. So jump on no carry. What it will do? It will check your carry flag. If there is no carry, it will do the some operation. So for that I have to give some loop. Okay, so whenever there is no carry, it will do these operation. Okay, so it will go to this loop, it will just increment the DPTR. So from 4201 it will increment to 4202, then whatever the value available at accumulator, that is 32, will be moved to the address 4202. Okay, and then it will store the value R0 in the next address. So suppose if you want, you can store in the next address. Okay, so let me use the next address in order to store your carry also. So this address is used to store the sum, this address is used to store the carry. So 4203. So you can further proceed the instruction like increment DPTR. Okay, so what is the R0 value? It is 00. So we cannot directly move R0 to the address here. First we need to move the value of R0 to the accumulator. So we have to use the instruction A comma R0. So whatever the value at R0, that will be moved to A. So whenever there is no carry, it will come here. So here R0 value is 00. So now 00 is moved to the accumulator. Okay. So here the DPTR value, is nothing but 4202, right? So DPTR, once it has been incremented to 4202, then only you are storing the A value at 4202. Now again you are incrementing the DPTR, so that DPTR value is 4203. So that location I am storing the carry. So carry is available in R0. Okay, so this is nothing but carry here. Okay, this carry I am moving to accumulator, then accumulator value I am moving to DPTR. Okay, so MOVX at of DPTR, so that whatever the value available at R0 is moved to this location. So R0 value is moved to this location. So actually R0 here it is 00, that is moved here. Okay, then you can stop the program. So what you can use, just yes jump here. So yes jump is nothing but short jump. So if you do like this, the program will again and again, it will become an infinite loop. So here itself it will stop the program. Okay, so jump on no carry means it will check your carry flag. So whenever carry is equal to 0, it will come here to the loop, then it will do all these operations. Okay, suppose if there is a carry, what I have to do? So this carry value is stored in the register R0. So this R0 value I have to increment. So previously R0 value is a 00. So now I have to increment your R0. So one more instruction I have to give, which is nothing but increment R0. Okay, so that R0 becomes what? Previously it was 0, now it becomes 1. So R0 becomes 1. So jump on no carry means it will come here. If there is a carry, suppose if there is a carry, okay, then it will not go to the loop, it will execute the next instruction. Okay, if the condition is satisfied only, it will go to the loop. If the condition is not satisfied, for example, my carry flag is equal to 1. If the condition is not satisfied, it will increment the R0. So increment the R0 means R0 value becomes 1. Then it will increment the DPTR 4202, A value will be stored at this place. Then incrementing DPTR come to this location. Okay. Then R0 value now it is 1. 1 will be moved to the accumulator. Okay. So previously it was 0 0, but now suppose this condition is satisfied. Now R0 becomes 0 1. Okay. So that 0 1 will be stored into the next location, that is 4203. Okay. So if there is no carry, it will store 0 0. If there is a carry, it will store 0 1 according to the addition operation. Okay. So this is the program for your 8-bit addition from the external memory. So you are getting the 8-bit data from the external memory and you are storing the result also in the external memory. Okay. Thank you. Thanks for watching.